You've probably seen them in awesome videos, or in person if you live in a place with heavy snow. Absolutely massive trucks pushing tons of compacted snow while everything around them seems to be at a complete standstill because of the storm. But what almost nobody knows is that they're not just simply removing snow. These trucks carry strategic weight, scrape with pinpoint precision, spread chemicals, constantly calculate and repeat the end-on process for endless hours so that the roads don't collapse under the snow. Today, we're going to take a look at exactly how snowplow trucks really work from the inside, why their design is absolutely key to keeping cities moving when winter gives absolutely no breaks, and what hidden technology they use to work in conditions that would stop any other vehicle in its tracks. But before we dive into this fascinating world of extreme engineering, if you're passionate about learning how the world's most powerful machines work, give this video a like and subscribe to the channel so you don't miss more content like this about heavy engineering. Now, get ready to discover secrets that very few people know. When we think of a typical snowplow truck, most of us imagine something very simple and straightforward. A big truck pushing snow to the side of the road, and that's it. But in the real world, a snowplow truck is a complete and integrated work system, specifically designed to operate for hours in absolutely extreme conditions that would kill any normal engine. The front plow is just the most visible and obvious part, but definitely not the most important part of the system. Its specific shape, its calculated angle, and its distributed weight are meticulously designed to move large volumes of snow without losing stability or damaging the road pavement. The front blade pushes the snow forward, but it also directs it strategically. It doesn't lift it like many people think. It channels it in a controlled way. That's why it has specific calculated angles, and in many cases side extensions that allow it to clear more than one lane in a single efficient pass. Mounted on the back of the truck is another absolutely key component, the salt or sand spreader. Its function isn't to melt the snow instantly like in cartoons, but to prevent ice from forming and turning the road into a deadly skating rink. This entire complex system is controlled with high-power industrial hydraulics. The operator can raise, lower, tilt, and/or turn the plow in real time, even while the truck is moving at a constant speed. For all of this to work correctly, the truck needs real and effective traction. Axles reinforced with special steel, locking differentials, and in many cases, all-wheel drive on all 6 or 8 wheels. These systems allow the truck to keep moving where a normal vehicle would simply get completely stuck and need a rescue. And perhaps the most brutal part of all, these trucks don't work for short periods. During a severe storm, they can operate in shifts of 12, 16, or even 24 hours straight, because the snow doesn't wait, and the roads can't stay closed either. Now think carefully about this. A snowplow is moving at 30 or 40 miles per hour pushing snow. What happens if the blade hits a manhole cover, a deep crack, or a concrete curb hidden under the snow in a normal truck? That would be an absolutely brutal impact that could break everything. But this is where one of the most important and ingenious systems of the snowplow comes in. Snowplow blades are not rigidly fixed to the truck's chassis as you might think. They incorporate a system called a trip edge, based on heavy-duty safety springs. When the blade hits a solid obstacle, the blade folds back, completely absorbing the impact, and in the same motion, the steel springs automatically return it to its original position. The plow doesn't break, it doesn't violently lift the truck, and it doesn't throw the operator forward. The blade is literally alive. It moves, adapts instantly, and recovers on its own. Without this ingenious system, every impact could damage the transmission, the chassis, or even cause a serious accident with casualties. And when you're working at night with almost zero visibility, these impacts aren't the exception. They are a constant part of the daily job. And there's still another key technical detail that very few people notice. The cutting edge of the blade on many snowplows is made of tungsten carbide. It's the exact same material used in high-precision industrial cutting tools. It's extremely hard, resistant to wear, and designed to work against aggressive surfaces. This edge isn't meant to last forever. It's designed to wear down first, protecting the entire plow and the truck. It's a sacrificial part that is replaced every season. Something that really catches the eye of those in the know is this. These are heavy-duty work trucks that push tons of snow. So why don't many snowplows use traditional manual transmissions? In a snowplow, the most important thing isn't top speed. It's not stopping pushing for even a second. Every time a manual transmission shifts gears, there's a momentary interruption of torque. And in compacted snow, that lost second is enough for the truck to slow down or lose traction completely. If you stop pushing for even an instant, the snow stops you. That's why many modern fleets use heavy-duty automatic transmissions, like the legendary Allison transmissions. They allow for continuous, smooth shifts without cutting power to the drive wheels. These transmissions maintain constant pushing force as the truck moves forward, even at low working speeds. Additionally, they dramatically reduce operator fatigue, which is absolutely key when you're working 12 or 16-hour shifts without a break. And now for a little-known trick that veteran operators use. The salt you see loaded in the back of the truck isn't just there to be spread on the road. It also works as a calculated, strategic ballast. That extra weight helps the rear axle get much more grip, right when the front blade is pushing snow and trying to pull the truck towards the ditch. Without that distributed weight in the back, the truck would tend to skid or be pushed straight off the road. So far, we've talked about brute force, weight, and heavy mechanics. But here comes something that almost nobody expects to discover. Snow isn't just removed with physical force. It's also removed with applied chemistry, and yes, in many cases with something very similar to beet juice. And it sounds weird, but it's pure science. For years, the solution was absolutely simple: common salt. The problem is that when the temperature drops below about 15 degrees Fahrenheit, salt stops being effective completely. In extreme cold, the crystals don't stick well to the asphalt, and the chemical reaction becomes too slow to be useful. The practical result: you throw salt, and absolutely nothing happens. That's why many modern snowplow trucks use advanced pre-wetting systems. Instead of traditional dry salt, they apply a liquid brine, a concentrated liquid mixture of water and salt. Being liquid, it adheres better to the pavement and starts working immediately. But for even lower extreme temperatures, brine alone isn't enough to keep the ice at bay. That's where mixtures based on beet juice or industrial molasses come in. These liquids contain sugars that lower the freezing point and help the mixture keep working, even in extreme cold of -5 degrees Fahrenheit or lower. It's not that they melt the snow on their own. What they do is allow the salt to keep reacting when it normally would have stopped. This isn't some field improvisation. It's materials science applied to asphalt. And what you're seeing on the screen is not a camera error or a special effect. This truck isn't skidding out of control. It's intentionally crabbing or dog tracking down the highway. In some areas, especially on multi-lane highways, a single truck can clear more than one full lane at a time. How does it do it without magic? With hydraulic side displacement trailers. These trailers don't follow the truck like a normal, traditional trailer, and they have steerable axles that can turn completely independently. While the truck moves in a straight line, the operator can shift the trailer to one side or the other, covering up to 3 full lanes in a single, efficient pass. All of this happens without losing stability and without dangerously encroaching on the opposite lane. It's pure engineering applied to a very specific problem: clearing roads quickly with fewer vehicles and less risk of accidents. To handle this entire complex system, the operator doesn't just use a traditional steering wheel. They use a control panel full of hydraulic levers, switches, and function buttons. From there, they control the front plow, the side wings, the salt spreader, and also the exact position of the trailer. It doesn't look like the cab of a normal truck, and it looks like the cockpit of a commercial airplane. That's why this type of setup is considered the final boss of snowplow trucks. Not all snowplow trucks are the same, nor do they work in the same way. In the United States, very different configurations are used depending on the type of road, the amount of snow, and the severity of the regional winter. That's why they are usually divided into three main categories. Medium-duty trucks. This is the first line of defense in cities and small towns. Here we find models like the Freightliner M2, the International MV, and the Ford F750. They are relatively compact, agile, and easy to maneuver, ideal for narrow streets, residential areas, and secondary roads. A truck of this type can move several tons of snow per hour and work shifts of up to 12 hours straight, and especially during moderate storms. When the snow is heavy and the roads are long highways, the true heavyweights come in. Models like the International HH, the Freightliner 114SD, or the Western Star 4700 and 4900 are designed to push snow for hours without a break. They have reinforced chassis with high-strength steel, more robust axles, and engines designed to maintain constant torque, not maximum speed. In extreme storm conditions, a single heavy-duty truck can move tens of tons of snow per shift and operate for 16 hours or more with minimal breaks. And then there are the extreme beasts that look like they're straight out of science fiction and that most people will never see in person. Here, we're talking about vehicles like the Oshkosh trucks used at international airports and strategic military bases, capable of clearing entire runways in a single quick pass. These monsters can have up to 8 drive wheels, engines with more than 500 horsepower, and plows that are over 20 feet wide. They are so large that they need 2 operators working simultaneously to control all the systems. Or the legendary Mercedes Unimog, world famous for its traction in extreme mountainous areas, impossible slopes exceeding 45 degrees, and roads where a normal truck literally wouldn't survive or even make it. The Unimog has a unique articulation capability that allows it to keep all 4 wheels in contact with the ground, even on completely uneven terrain. Its traction system can distribute power independently to each wheel as needed. Also in this category are articulated trucks with extendable side wings, capable of covering up to 4 full lanes at the same time without needing to make multiple passes. These machines can literally move hundreds of tons of snow in a full workday and operate practically non-stop while the storm continues to rage. And there are even more specialized configurations. In Alaska and in the Arctic regions of Canada, there are snowplows that operate at temperatures of -40 degrees Fahrenheit. These trucks have engine preheating systems that must run for hours before starting. They have special oils that don't freeze, diesel fuel treated with anti-gel additives, and cabins with heating systems that consume as much energy as a small house. The tires are special, with rubber compounds that remain flexible even at extreme temperatures. In some mountainous areas of Colorado and Wyoming, these snowplows, equipped with controlled explosives, are used, no joke, when snow accumulates on dangerous slopes, forming cornices that could cause avalanches. These trucks carry explosive charge launchers that detonate the snow in a controlled manner before it falls onto the road. None of this is cheap or accessible. A new, well-equipped snowplow with all the systems can cost between $140,000 and $500,000, depending on the size, hydraulic systems, and specialized accessories. If you look closely at the fleets, many snowplow trucks are not shiny and new. In fact, some have been in active service for decades, and it's not due to a lack of government budget. It's because they have to last for generations. Most use large, proven, traditional engine designs, nothing with record-breaking power figures. And what matters is constant torque and absolute reliability. They are engines that can work for hours at low RPMs without unnecessary stress that would destroy them. Another key point: little complex electronics. Fewer sensors that can fail, fewer modules, and fewer things that can go wrong in extreme cold. When you're working at -5 degrees Fahrenheit, simplicity isn't a luxury, it's a survival advantage. That's why they continue to use robust automatic transmissions, or in smaller models, very sturdy manuals. Transmissions designed for continuous heavy-duty work, not for efficiency on paper. They shift when they need to, without unnecessarily punishing the drivetrain. And the chassis of a snowplow lives a really tough life. Constant impacts, vibrations, twisting, and tons of constant pushing. That's why they are reinforced structures, designed for daily abuse, not to look good in a catalog. But the biggest enemy of these trucks isn't the snow or the cold, it's the corrosive salt. Salt accelerates corrosion like few other materials, and yet these trucks remain in service. The secret: constant and religious maintenance. Frequent washing of the chassis, especially after each storm. Application of anti-corrosion protections, special coatings, and parts designed to be replaced when they rust. It's not about preventing rust altogether, but about making sure corrosion never wins the final battle. That's why you see snowplow trucks that are 15 or 20 years old still working perfectly. But no truck, no matter how tough, moves on its own or makes decisions. Behind every snowplow is a real person working in brutal conditions. During a severe storm, the normal 8-hour shifts completely disappear and are forgotten. Many operators work 12, 14, or even 16 hours straight with minimal 15-minute breaks. The priority isn't to finish the shift warm and comfortable. It's to keep the road open and safe for emergency traffic. Most of the time, the operator doesn't see the road clearly in front of them. They see intensely falling snow, blurry lights, and confusing reflections on the windshield. The line between the asphalt, the dangerous ditch, and the oncoming lane often simply doesn't exist visually. Every pass can hide something potentially dangerous or deadly. A raised manhole cover, a stalled vehicle without lights, a pedestrian walking, or an invisible patch of black ice. The margin for error is minimal, and then the consequences can be fatal for both the operator and others. And perhaps the most psychologically tough part is something that no one mentions in the job descriptions. These trucks work precisely when everyone else is taking shelter in their homes, in the dead of night, in extreme cold, and when no one else wants to be outside for even a minute. But there's more to add about modern technology. The newest snowplows come equipped with precision GPS that maps exactly where the truck has been. This prevents clearing the same area twice, while other areas remain unattended. Some advanced systems even use sensors that detect the pavement temperature in real time. Why does this matter? Because the amount of salt needed varies depending on the exact temperature of the asphalt. Too much salt is a costly waste and pollutes. Too little salt, and the ice forms anyway. Modern systems calculate the exact amount needed and automatically adjust the spreader's speed. This can save thousands of dollars in each storm and significantly reduce the environmental impact. And there are cameras everywhere on the new models. Front, rear, side cameras, and some even have thermal cameras that detect heat. These can identify crashed vehicles covered in snow, or people who might be in danger in the ditch. Communication is also critical. All trucks are connected by constant radio, with a control center that coordinates operations. If one truck breaks down, another must take its route immediately. If there's an accident, all nearby trucks are alerted to avoid the area or assist if necessary. Before you ask how much these operators earn, there's something important that almost no one tells you honestly, and that changes the whole perspective. Many snowplow drivers only do this specific job for 3 to 5 months a year, depending on how harsh the winter is. The rest of the time, if they work for the state or municipality, they maintain roads during the summer, fill potholes, paint lines, or do various public works. and if they are private contractors, as soon as the last snow melts. The job and the income literally disappear. But during the winter, when everything comes to a standstill due to storms, they can't stop for a second. Endless shifts, extreme cold that burns exposed skin, zero visibility and constant danger. And it's precisely in those few months where most of their entire annual salary is at stake. The average salary can vary greatly, but between $40,000 and $70,000 annually, depending on the state, the operator's experience, and whether they work for the public or private sector. States with more severe winters like Minnesota, Wisconsin, or Maine tend to pay better, but that money is earned by working in conditions that most people wouldn't endure for a single full day. It's not just driving a big truck, it's making split-second decisions that can save lives or cause accidents. It's dealing with impatient drivers who pass you dangerously. It's knowing that if you fail, ambulances won't be able to get to emergencies. It's the responsibility of keeping an entire city running while it sleeps. And now for the honest question you should ask yourself. Would you do this job for that annual salary? Would you spend 16 hours straight pushing snow at -5 degrees Fahrenheit, knowing that thousands of people depend on you? Could you handle the pressure of knowing that one mistake could cost lives? It's easy to see these trucks from the outside and think they just push snow, but now you know the truth. They are incredibly complex machines operated by people who do a job that most people couldn't or wouldn't want to do. If this video made you appreciate the work of these operators and the impressive engineering behind these machines, don't forget to give it a like, share it with someone who lives in a snowy area, and subscribe to the channel for more content on extreme engineering and heavy machinery. Let us know in the comments if you've ever seen one of these trucks in action, or if you live in an area where they are indispensable every winter. Tell us about your experience. We'll see you in the next video, where we'll continue to explore the most fascinating engineering in the world.